And thanks for everyone for participating in today's webinar, Effective Physical Security for Electric Substations. As you can see by my gray hair, I've been around the industry quite a while. I'm a life senior member of IEEE. I've done just about everything you can in the electric industry. I've worked in substations. I've worked as a lineman. I've worked in substation design, transmission system operations. I've authored a textbook on protective relaying. And I've actually installed security systems at 2 nuclear power plants, the Susquehanna nuclear power plant in Pennsylvania and the Fitzpatrick nuclear power plant on the shores of Lake Ontario in New York State. What we're going to discuss today, first we're going to discuss why substation security is not enough today. We're going to examine threats to physical security and past incidents. We're going to review the classifications of substations. In our world, in prescient transmission, we have 3 classifications of substations, and we want to go over that with you. We want to introduce the SHIELDR method of effective substation security. That's different than traditional security that's law enforcement prescribes. And then we want to discuss how Prescient can help utilities implement the SHIELDR principles. Today's substation security, it's not enough. The energy grid is a really soft target. You got to remember that the energy grid is a 3-machine system. You've got one machine that's everywhere east of the Rocky Mountains. You've got a second machine that's everywhere west of the Rocky Mountains, and you've got the Texas machine. And all our substations are unmanned. The response times when things happen are way, way too long. My gut feel is that if a 3-phase fault remains on a transmission system for 100 milliseconds, we're at risk of a wide area blackout. If a 3-phase fault remains on a transmission system for 250 milliseconds, we are certainly going to have a wide area blackout. And before you can start developing a security system, you have to understand the motives of the people who are going to do us harm. So thinking about this, the 5 traditional Ds of security, they don't meet the need. A fence around a substation does not deter someone from trying to attack a substation. It doesn't delay it, and it doesn't defend it. So we have to think of a better way to protect our substations. And when I start looking at the threats, a single disgruntled employee who has access to any transmission substation can create a multi-state blackout. And if a paramilitary group uses internet knowledge, they can attack any open-air substation and cause a multi-state blackout. You got to remember, our grid is 1 machine. It's really it's 3 machines. So think of the whole East Coast as 1 machine. And law enforcement response to incidents in substations is going to be urgent rather than crime in progress. And we have to change our response so that utilities always respond with proceed and caution when intruders are in a substation. We have to recognize that there are as many guns as there are people in the United States. And some of the people who want to do harm may be armed. And when I start looking at security, I don't think in terms of a security officer. I think in terms of the expert opinions you need to secure a substation. You have to have the substation engineers involved. These are the people who are designing the substations and building the product for us. Transmission or transformer subject matter experts have to get involved so we can come up with better, cooler configurations. System operators, they all know all the weak points of the system, and they should be verifying that what we're doing is appropriate. Protective relay staffs, they assess failure modes. They know where the key critical failures are, and they should be involved. The security response team should be responsible for personnel safety, and maintenance teams are responsible for directing recovery. So when I think of physical security, I'm thinking I want to have a team effort. I don't want a security person just handling this by themselves. And then there are other important costs to consider. Whenever I do anything for utility, the first question that comes up is, how much is it going to cost me to do this? Is it going to cost me $1 million or is it going to cost me $10,000? And in today's world, there's other important costs that we have to consider. The first is NERC. If there's a incident at a NERC monitored substation, they're going to come in and they're going to investigate. And there's always the possibility that you could wind up with a civil penalty coming out of it. So you got to remember that there could be NERC costs for a physical security challenge. And then state agencies, they presently don't have any requirements out there for substations, but they're going to question past practice after something happens. And we're always worried about the trial lawyer initiated lawsuits. Where we live in Oregon, the trial lawyers are initiating a lot of lawsuits based on wildfire ignition. We don't want something like that to also happen based on security, because they do result in multi-million-dollar settlements. And the cost to repair and replace damaged equipment is expensive. Transformers are expensive. Substations are expensive. And then you have the customer losses and the customer mistrust. So these are other costs that we normally don't put into our considerations, but we should. When I look at the threats to substation security, the biggest threat that I'm concerned about is a disgruntled employee. Fortunately, that's a low probability event, but it's really high risk, because disgruntled employees, they have insider knowledge. They know where the substations are. They know where the controls are. They know where the locks are. So we should be designing our substations so that a single disgruntled employee can't get in there and cause harm. The second threat is a paramilitary group. And I'm thinking that that's a moderate probability, a moderate risk event. The concern we have is that there's so much information on the internet out there. If you pick a city, any city or any state, and ask me how long does it take for me to identify a critical substation in that state, the answer I'll give you is 5 minutes. So I can go on the internet in 5 minutes, find out where a critical substation is. And within that 5 minutes, I can also go on Google Maps and get an aerial view of the substation. And I can also get a street view. So there's a lot of information out there that we have to understand that it's presenting additional risks to our products. And activists are moderate probability of a risk, moderate risk, and they typically use intellectual resources to increase social awareness. And we had an activist in the Northeast here who unbolted transmission towers. It was his way of trying to drive home the fragility of the power grid. And then you have thieves and vandals. Thieves and vandals, high probability, low risk. They're opportunists. They're going to steal ground mats. They're going to steal whatever they can. So there's a high probability that they go in. Any of those could perform acts of vandalism or sabotage. A disgruntled employee, his goal is sabotage. A thief or a vandal, they're just in there to see what they could steal out of a substation. So if you think about physical security incidents, back in April of 2013, when the gunman attacked Pacific Gas and Electric Company's Metcalf substation, they damaged 17 transformers, and the electric utility industry didn't do much about it until Fox News did an expose on it, and then there were Senate hearings, and within 9 months, NERC, Physical Security Standard, was updated in 9 months, which in utility time is incredibly fast. In December of 2020, we had the RV, which was loaded with explosives, and it was detonated outside of a telecommunications office. That's the type of thing that we should be worrying about in the electric utility industry. And then in December of 2022, we had the North Carolina shootings where we had 40,000 customers without electric power for a few days. And just as recently as last Christmas Eve on December of 2023, an intruder got into a 230 kV substation in Northampton, Pennsylvania, got inside a transformer to steal the windings, and then became trapped. and he was discovered because he had to call 911 for someone to get him out of the transformer. So these kind of things, they're happening across all industries, and the electric power industry is no exception. So I'm looking at the three classifications of substations. There's the critical transmission substations. NERC has a reliability standard, a critical infrastructure protection standard 14. CIP 14 applies to about 1,000 substations. There are another 5,000 substations that don't fall under CIP 14 criteria. And then there's neighborhood substations. So these are the three classifications of substations as we see it. There's critical per NERC, other transmission substations, and then neighborhood substations. If I look at a substation, this is a saboteur's view of a substation. And the way I got this picture of a substation is I looked for an article about people opposed to a substation. And people want this substation here to have a roof put over it so that it's not an eyesore in the community. And what they did is they went into a nearby apartment and took some really nice pictures to publicize in the paper as to why this substation should be covered with a roof. So you got to remember that when saboteurs are looking at a substation, they have the internet, but after they're done with the internet, they can find apartment buildings, parking garages, office buildings, a lot of things that are taller than the substation to look in and decide what are the critical components in the substation. So when I look at critical transmission substations, these are the ones that are under critical NERC, Critical Infrastructure Protection Standard 14. That's the physical security standard for NERC substations. NERC substations are 100 kV and above, and there's approximately 1,000 substations in this category, and they must be very secure. The worst case issue is that a disgruntled employee sabotages critical components, and the consequences are statewide blackouts with millions of customers affected. The reason why I focus on disgruntled employees is if we solve the disgruntled employee concern, we're going to solve this. We're going to have solutions for all the other threats that could occur in a electric substation. So if I look at the transmission class substations, now these are substations that are operating above 100 kV, and there's about 5,000 transmission class substations that aren't subject to CIP 14. And these substations should be secure, because once again, the worst case is a disgruntled employee sabotages critical components, and the consequences are regional blackouts, probably 100,000 customers interrupted. And when I'm looking at this, I'm saying, like, how do I decide what substations I really have to secure? Well, there's an analysis that electricals use. It's called fault-induced delayed voltage recovery. And fault-induced delayed voltage recovery says that there's a fault on the system, and the fault's been on the system for at least 250 milliseconds. And is the grid going to respond, and is it going to get back to normal, or is it going to collapse? So if you do FIDVR analysis, that should tell me where my critical transmission substations are. And the neighborhood substations, there's like 70,000 substations in the United States. And it's a local concern if they're sabotaged. This should be all the stations should be secure. The consequences are you're going to have maybe 25,000 customers interrupted when a fault occurs if someone sabotages a neighborhood substation. My own personal experience with a substation blackout happened in 2006 in Queens, New York. And this was in August, and the substation was out of service for 8 days. 8 days in New York City in August, it was a challenge. So Mayor Bloomberg held a press conference outside the substation for all 8 days. And his focus was, why did this happen? And the electric utility would explain what would happen. And then Mayor Bloomberg would ask questions that kept them on the spot. So we're talking about changing security, and we're talking about SHIELDR, which is effective substation security. And SHIELDR is our acronym for strategically hardening, isolating, examining on location, duplicate, and react and recover. So I'm thinking that our principles, the SHIELDR principles, we acknowledge that there's the vast amounts of data available on the internet, and you're going to plan for the worst case scenarios, and you require all your subject matter experts to participate. You acknowledge there are limitations to what we can do, so you try to be strategic, you try to be flexible, and you create plans to react and recover after the sabotage occurs. So if I'm looking at strategically hardening, a lot of our substations are outdoor substations. They're just sitting targets, no other way to describe them. Today, when I looked for a enclosed substation, what I did is I went on the internet and I found a critical substation location. And then I went on Google Maps and got a picture of what the building looked like. And this looks like a transmission class substation that has a gantry crane in the building. So the building is like 80 feet tall. It looks like a fortress from outside. I think that we should be constructing low profile industrial shell buildings like the one on the left. And we should build the buildings to match whatever's in the area. And our substations don't have to be more than 30 feet tall. The reason why they're really tall today is because we're putting gantry cranes in them. If we have all skid mounted equipment, we can easily conceal components inside of buildings. And sometimes in major city areas, the components could be inside parking garages. So the first two levels of the parking garage are a substation, and the upper levels are parking. I also think that we should have no aerial components within a half-mile of a substation. When you are driving around your neighborhood, see if you can pick out Verizon switching stations. There's a lot of Verizon switching stations out there, and the easiest way to pick them out is to drive around at between 7 o'clock and 8 o'clock in the morning, when they have a lot of Verizon vehicles on the street outside the facility. So we should be providing off-street parking so that people can't drive by early in the morning and figure out where our substations are. We should be installing bulletproof heat exchangers. And the bulletproof heat exchanger on the slide here, this is one that we've put a metal barrier around the cooling fins. And this is a partial view of what one would look like. We should be putting in motorized transformer cooler isolation valves. Shooting a hole in a cooler doesn't really damage the transformer. What happens is the oil drains down, and then you lose insulation strength inside the transformer, and a surge occurs and the transformer fails. So if we recognized that we were losing oil out of a transformer, we would operate transformer cooler isolation valves, button the transformer up, minimize the possibility of transformer failure. All my components in substations, we should be using plug jack, high voltage electrical connections. We should get away from using transformer bushings and circuit breaker bushings. These plug jack connectors are used wherever I'm building a gas insulated substation. I bring in insulated cables to the substation. I use a plug jack to connect up to the buswork. And I should be putting in tamper resistant cabinet doors. It should be really difficult to open any control cabinet door on any component in a substation unless you have the access keys to get in there. And we should be requiring sally ports at all access points. When I work in a nuclear plant, I go through one door, I get into an area, close the door behind me, and then I can open the second door to get into the area I want to get in. That's a sally port. A sally port is just someplace where you have dwell time before you can open the second door to access it. When I talk about isolation, within a substation, I should have service groups. I should have service groups like A, B, C, D, and eliminate the line of fire between the service groups. This is a neighborhood substation that's built with 4 transformers and almost 4 service groups. So if you look right here where my pointer's over, that's a transformer bay. That transformer bay has in it the 138 kV cables coming in. It has a 138 kV circuit breaker in it, and it has a 138 to 13.8 kV transformer. The same is true in this transformer bay, and I've got two transformer bays over here that it's true. So what they've done is they've created 4 service groups so that if someone decides to attack one of the service groups, they can't get all 4 transformers in the station at the same time. They've eliminated line of fire corridors. They've put firewalls between groups, and they've put bulkhead doors between groups. And they're putting electric isolators between service groups. Electric isolators in my world is circuit breakers. But I use the term electric isolators to drive home the point that a circuit breaker is an isolation device. And they required physical separation of the redundant protective relaying scheme. So some utilities are doing this. A lot of utilities are not. When I talk about examining on location, the first is installing cameras in buildings so you'll have an awareness of who's on site. And then you want to install position switches on doors and cabinets, access panels, gates, so that when someone opens a cabinet or opens a panel, they've already alerted security that they're going to do that. If someone opens it and they haven't alerted security, then security is going to come out and ask, like, what are you doing out here? So we're going to implement key card access systems. And the key card access systems would be actually within the station. So if you use your card to get into a substation, then you use your card to get into a transformer bay, you use your card to get out of the transformer bay, and then use your card to leave the station. And single person alarms, we shouldn't have single individuals able to access critical substations. What we should do is have it set up so that if 2 people aren't in a critical substation within 5 minutes of each other, security is alerted and security comes out to the site and asks a question. Why are you here? What are you doing? And then we should be performing annual sabotage drills where we simulate an intrusion, we simulate sabotage, we simulate response, and we simulate recovery. This would be an 8-hour drill at a specific substation. You do a different substation every year. And the assumption is that all groups that are going to participate through recovery get a chance to participate in these drills. When I'm talking about duplicating, this is a control house fire. This control house was set on fire in Arkansas. I think about 2013, there was someone down there who who sabotaged many components before they finally caught him. So what you want to do is have redundant components in there, service group 1 and service group 2, which says I would have 2 batteries, battery 1, battery 2. Battery 1 would power up service group 1, battery 2 would power up service group 2. So we're trying to eliminate single points of failure. So if one incident occurs, it can't take out 2 or more components. This means that we should be implementing 2 relay and control rooms, 2 battery rooms, and 2 trip paths to every circuit breaker. And when I talk about trip paths, I mean that you can't put the redundant cables in the same cable tray or the same conduit. This is something that the nuclear power industry has been doing for the last 40 years, and it's something that we should embrace. When I talk about react and recovery, the operations staff, they monitor all the equipment in our substations. They're watching for transformer overloads. They're watching for relay failures. They're watching for a whole bunch of things. They're watching for trip outs. So operations staff's already monitoring all our equipment. Security personnel should be monitoring the facilities to see if the people that are on site actually belong on site. And first responders have to include both law enforcement and utility personnel. When you have an intruder in a substation, you don't know if he's armed, and you want law enforcement to be out there to assist. Recovery workers are going to include utility workers and contractors, and you always assumed intruders are armed. And our reaction goals, we're thinking in a transmission facility, I want people to be able to respond within 15 minutes. And with a neighborhood facility, I want people able to respond within 30 minutes. That response within 15 minutes means to me that I want to harden things so that someone can't go in and sabotage critical components in 1 minute. It takes them a substantial amount of time to sabotage components. And the recovery goals I'm looking at, I want transmission facilities to be recovered within 24 hours and neighborhood facilities to be recovered within 72 hours. And that means that we probably have to change some of the ways we're doing our maintenance and repair activities. It probably means we have to have more spare equipment and more plans set up to implement the spare or to utilize the spare equipment. So I'm looking at this, and I always like to see how effective we are. So what we did is put together a matrix like this that compares the traditional approach and the SHIELDR approach for disgruntled employees, for a paramilitary group, for an activist, and for a thief and a vandal. So I'm looking at the traditional approach. The traditional approach is maybe effective. I'm not sure how effective it is. So I'm going to rank it 2 in my matrix here. In isolation, there's not a lot of isolation between components in substations. So maybe it's effective, maybe it's not. Examining on location, I don't see that happening effectively today, so I just rated that as ineffective. Duplicate is ineffective because most of the substations I go to have one big control house. Some of them have 2 batteries, but they always have one control house for some reason. And react and recover, we don't have any plans for how quickly people have to get out to a substation. And so I'm looking at react and recover a 1. So the effectiveness score for today's security, I rate that as 7. And you're saying, well, what can I do for disgruntled employees? Well, I can come up with things to harden it so that disgruntled employees can't create a 3-phase fault. One of the easiest things for a disgruntled employee to do is go find a air brake switch and open the air brake switch with a handle. Most of the air brake switches I have out there are gang operated, which means all 3 phases open at the same time with one handle. If I want to strategically harden a substation, I could just convert that 3-pole switch to 3 single-phase switches. So then a disgruntled employee who wants to operate that switch to create a fault, they could open 1 phase, which would create a single-phase to ground fault, and then that line would be tripped out of service, and he wouldn't be able to create a 3-phase fault. When I look at isolating, if I start putting in service groups so that one person can't damage all the service groups in a station at the same time, that gives me a ranking of 4. Examine on location. Examine on location is a big thing because what I'm going to do is look at my substations, take out my subject matter experts, take out my security people, examine the station, find the weak points, and then duplicate to eliminate weak points and come up with plans to react and recover. So I can move my effectiveness score up to 23 from 7. And the effectiveness score assignments I've come up with is if this total comes up to more than 20, it's highly effective. If it's greater than 15, it's effective. And if it's less than 15, it's ineffective. And the traditional approaches that I'm using today, I consider them to be largely ineffective. So I'm thinking that traditional physical security, that's the best efforts of honest engineers. Honest engineers find it difficult to anticipate what someone who's irrational is going to do. And I think physical security has to match cybersecurity. Critical Infrastructure Protection Reliability Standard 14 is the only physical security standard that applies to substation. There are 12 standards that apply to cybersecurity. So I'm thinking if we have 12 cybersecurity NERC standards, we probably have to enhance 14 to cover a lot of the issues that are in the 12 cybersecurity issues. And the react and recovery has to be commensurate with the impact and the damage that you could have at a substation. I recognize that you don't want to spend $10 million to protect a $1 million substation. But on the other side of the coin, I think you only want to spend maybe $10,000 a year to monitor a substation for intrusions. But my thoughts are that physically secure substations, they're going to be safer and they're going to be more reliable than the stations I'm building today. So I think you have to include SHIELDR principles in all new substations. A lot of our substations are aged. Up until 1970, the demand on the electric power grid was increasing at 6% per year, every year for a long time. And we built a lot of capacity to serve the load that we expected to double every few years. Since the 1970s, load hasn't been growing as quickly. So what we've done is we've allowed a lot of stations to age out. So when we're putting in new transmission substations, we should be designing those substations to withstand sabotage by a disgruntled employee. And we should be concealing our facilities from paramilitary groups. And the existing stations that we're going to leave in service, we should be coming up with prudent enhancements at those neighborhood substations. So I'm looking at this, and every substation should have a physical security assessment team. I should say every utility should have a physical security assessment team. You've got the civil engineering team that's looking at the site design, the structural engineering team that's looking at the building and the structure design, the physical electrical team that's looking at the component placement and operation, the protection and the control schemes looking at the wiring and the control scheme design to make sure that there are no single failure points in there. And system operators should be establishing limiting conditions of operation. If you establish limiting conditions of operation, which says, if I'm going to replace a substation transformer, I'm going to replace it in 7 days, then 7 days would be the amount of time that I would be allowing to replace a transformer that's been sabotaged by someone. And we need security personnel to establish monitoring and to react to things that are happening in there. And Prescient transmission systems, we're here to validate the security that you've installed in your substations. So we were ready to work with utilities to implement the SHIELDR method. We're thinking that that should be put in all new substations starting today. And the principles should be reviewed for all the critical transmission substations you have. These evaluations should be low cost. So we're here to help utilities identify prudent, cost-effective physical security enhancements that could be made to critical transmission substations, other transmission substations, and neighborhood substations. We want to help utilities prepare for unlikely but predictable actions of saboteurs, vandals, and criminals.